Okay, so today we talked about complex numbers. Complex numbers are used in the real world with fractals, and if you're going to try to do any electrical engineering type work, they also use complex numbers or imaginary numbers. So first thing is, imaginary number is represented by the letter I, and it's usually an italicized I. Sorry, I'm trying to make it clear. And the thing that you need to know is that I is equal to square root of negative 1. So anytime you see a square root of a negative, we're going to take that out and make it I. Alright? Then I squared is equal to negative 1. Alright, so if I took that square root and I squared it, these would cancel each other, and I would be left with negative 1. Alright, I cubed is equal to negative I. We could use that same process and get that. I to the fourth is equal to 1. And again, we could repeat the process and go from there. These two right here are the two most important. They're the ones we're going to be using the most. Okay? So make sure you remember what square root of negative 1 is I, and I squared is negative 1. Alright, complex numbers are the combination of a real number and an imaginary number. So this is a plus bi, that's the form it needs to be in. The a is the real component. So just like a regular number, 2, 3, 4, so on. And the bi would be your imaginary component. So whatever number ends up with the I. Okay, this is the form that it needs to be in. For it to be completely accurate. So make sure it's written with the real number plus imaginary number. Only if there is both of those two things. Alright. So example 1 is like what we did last week, where we simplified the radicals, but this time we're dealing with negative. I'm going to rewrite this as square root of negative times square root of 20. Okay, these are equivalent. Square root of negative 1, if we remember from above, is equal to I. So instead of square root of negative 1, I'm going to write I. Then square root of 20, I need to reduce. So the biggest perfect square that goes into 20 is 4. 4 times 5 is 20, so there we go. Square root of 4 is 2. Square root of 5, I can't go any further. So in order to write all of this combined, I'm going to have 2i square root of 5. And there's your answer. So let's look at the next example. Square root of negative 8. So again, I'm going to rewrite it as square root of negative 1 times square root of 8. That's I. The biggest perfect square that goes into 8 is 4. 4 times 2. Okay, square root of 4 is 2, and I'm left with 2 square root of 2. Then if we combine it all, I'm left with 2i square root of 2. Alright, example 3 is, what if I had a number on the outside? Well, that number gets multiplied by whatever you take out. So I have 2, that negative becomes an I, so I'm skipping this step, I don't have to write that. Square root of 16. Okay, well the square root of 16 is 4, so this is 2i times 4. Well, 2 times 4 is 8, so this is 8i. So if it helps you to write this step, then please do. If not, then just remember that that negative becomes the I, so you don't have to necessarily write that step. Alright, example 4. I have 5 plus 7i minus negative 2 plus 6i. This is like combining like terms. So wherever you see a real number, we're going to combine. Wherever you see an imaginary number, we're going to combine. So along with it being like terms, you have to do the same thing. Distribute that negative to both of these things. So 5 plus 7i plus 2, because the negative times the negative is positive, and then minus 6i. So when we combine our terms, I have my real numbers 5 and 2. When I combine them, I get 7. Oops, I should have put the equal over here. And then 7i minus 6i would give me a positive I. So my final answer is 7 plus I. Alright, now here I have 5i times 4i. So this would be like if I had 5x times 4x, that would give me 20x squared. Same thing here, but now it's just I. So this becomes 20i squared. Well, if you remember from up above, I squared is -1. So instead of I squared, I'm going to plug in -1. And when I do that, I get -20. So there's our answer there. Okay, so this and this one, example 4 and example 6 look alike. But the difference here is in example 4 we were subtracting. In example 6 we're multiplying. So in this we need to FOIL. So 2 times -3 is -6. 2 times 5i is 10i. 3i times -3i is -9i. And 3i times 5i is 15i squared. Okay, well, again, we're going to combine our like terms now. So I know 10i minus 9i is I. And I know I squared is -1, so this becomes -15. So if I combine -6 and -15, I get -21 plus I. Okay, example 7. If I have 4 minus 2i squared, well, anytime anything's squared, it means you're multiplying it by itself. So this is 4 minus 2i times 4 minus 2i. So again, we're going to use that same process here and FOIL. So 4 times 4 is 16. 4 times -2i is -8i. -8i plus 4i squared. Okay, again, I squared is -1, so this becomes -4. So 16 minus 4 is 12. And -8i minus 8i is -16i. So there's our answer for that. Last example. This is like combining our first 3 examples with example 4. So here, this becomes square root of 16, so I square root of 16, and square root of 16 is 4, so this is 4i. So I have 6 plus 4i. So here this is I square root of 4, square root of 4 is 2, so this becomes 2i. So I have 4 minus 2i, and then bring that plus down. Combine your like terms, so the real number is 6 plus 4 is 10. Imaginary number is 4 minus 2i is positive 2i. And there's our answer. Okay, the assignment that was given for this lesson is A15, page 282, 1 through 10 all, 30 through 40 evens, and 57 through 60 all. If you have any questions, please let me know, and good luck.